In a daring announcement, scientists have claimed to have discovered a new planet unlike anything previously known to humankind. This revelation comes with excitement and anticipation as it promises to expand our understanding of the cosmos. The planet, which has characteristics that set it apart from any other celestial body we have encountered, has stirred up significant interest in the scientific community. NASA, known for its groundbreaking contributions to space exploration, has been at the forefront of this discovery. Their team of researchers has revealed that this planet is extraordinary not only due to its massive size and distant location but also because it exhibits an unusual light that appears to be artificial. This raises a profound question: could we be on the brink of uncovering secrets that will transform our understanding of the universe? Furthermore, could this unusual finding point to the existence of life on other planets? These questions have fueled intrigue and wonder, and by delving deeper into NASA's incredible discoveries, we are bound to uncover the truth behind this extraordinary phenomenon. In 2007, NASA embarked on an ambitious mission by launching the Dawn spacecraft, designed to explore some of the most intriguing and mysterious objects in our solar system. This spacecraft was unlike traditional spacecraft due to its cutting-edge ion propulsion system, which was powered by 3 ion engines. These engines allowed Dawn to embark on a journey that would take it to study celestial bodies never before observed in such detail. The mission began with a 14-month-long intensive study of Vesta, the second-largest asteroid in the asteroid belt. Vesta, with its unique composition and history, became the subject of detailed imaging and data collection, revealing a surface that was complex and rich in geological history. Dawn's mission at Vesta provided new insights into this asteroid's diverse surface and its tumultuous history of impacts and volcanic activity. But after completing its primary mission at Vesta, Dawn's adventure was far from over. It then embarked on what many considered to be the most exciting part of its journey, a detailed study of the dwarf planet Ceres. What made this journey particularly fascinating was that Dawn, using its ion engines, was able to leave Vesta's orbit and set course for Ceres, an achievement that traditional chemical propulsion systems would not have allowed. The ion engines provided a constant, gentle thrust that enabled Dawn to travel great distances and enter a stable orbit around Ceres, a feat of engineering that opened a new chapter in space exploration. The dwarf planet Ceres, discovered in 1801 by the Italian astronomer Giuseppe Piazzi, holds a special place in astronomical history. Located in the asteroid belt between Mars and Jupiter, Ceres is the largest object in this region. For many years, Ceres was classified as a small planet and then as the smallest of the known dwarf planets following its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres is not only the largest object in the asteroid belt but also one of the most enigmatic due to its distinct characteristics. Scientists had eagerly anticipated the arrival of the Dawn spacecraft, which would provide the first detailed images and data from Ceres, a celestial body that had long remained shrouded in mystery. One of the most intriguing features discovered was the presence of bright spots scattered across its surface, particularly within a large crater known as a crater. These bright spots immediately caught the attention of scientists who began speculating about their origin and composition. Before Dawn's arrival, the best images of Ceres were blurry, low-resolution snapshots taken by the Hubble Space Telescope, offering only limited insight into its composition and surface features. The prospect of finally getting a detailed close-up of Ceres held the promise of significant scientific breakthroughs, particularly in understanding how planets and other large bodies in the solar system form and evolve over time. The primary objective of the Dawn mission was to improve our understanding of how the solar system was formed and to explore the role that water plays in the development of planetary bodies. Ceres offered a unique opportunity to study this in detail as it exhibited features unlike any other body in the asteroid belt. One of the most striking features observed on Ceres were the bright spots on its surface, which appeared to be composed of highly reflective material. These spots were of particular interest because similar bright spots had been observed on other asteroids. Scientists hypothesized that these spots could be made up of salts left behind by sublimated water. This theory suggested the possibility of cryovolcanism on Ceres, a process where instead of molten rock, water or brine erupts from beneath the surface. The notion that Ceres might still have active cryovolcanism sparked excitement and debate within the scientific community. What exactly were these mysterious lights, and what could they reveal about the internal workings of Ceres? Could they indicate that geological activity was still taking place, or did they point to something even more extraordinary and previously unseen? Ceres stands apart from other objects in the asteroid belt for several reasons. Its size and mass make it unique, but more importantly, its composition sets it apart. Unlike the predominantly rocky asteroids that make up much of the asteroid belt, Ceres has a composition more akin to that of a comet. This suggests that Ceres might hold important clues about the early solar system and how it formed. After spending 2 years traveling through space, the Dawn spacecraft finally approached Ceres in early 2015. This marked a significant milestone in space exploration, as it provided humanity with the first detailed close-up views of the largest object in the asteroid belt. As Dawn drew closer, it began sending back images of Ceres' surface, which were far more detailed than anything we had seen before. What emerged was a world that had long been hidden from view, now revealed in unprecedented detail. The surface was pockmarked, with craters telling the story of countless impacts over millions of years. However, what captured the attention of both scientists and the public were the mysterious bright spots scattered across its surface. These spots, set against the dark rocky terrain, glowed eerily, raising questions about their origin and what they could mean for our understanding of Ceres' geology and history. As scientists continued to examine the increasingly detailed images, they began formulating theories about the nature of these bright spots. The initial speculation was that they might be patches of ice reflecting sunlight, but as the data accumulated, more exotic theories began to emerge. Some scientists suggested that the spots could be mineral deposits, while others believed that they might be evidence of cryovolcanic activity. Volcanoes that spew water instead of molten rock. To everyone's surprise, closer inspection revealed that the brightest spot was not a single entity but a cluster of smaller spots grouped together. This discovery led to the most widely accepted hypothesis: the bright spots were deposits of salt left by the sublimation of water. This theory suggested that at some point in Ceres' history, and perhaps even in the present, there was geological activity beneath its surface capable of bringing water or brine up to the surface. Once exposed to the vacuum of space, the water evaporated, leaving behind these highly reflective salt deposits. The discovery of these bright spots challenged previous assumptions about Ceres, which had long been thought to be a cold and inactive world. Instead, Ceres appeared to be far more dynamic than expected, with a complex and evolving geological history. The possibility that there could still be water beneath its surface, or even pockets of brine, led to profound questions about the potential for life in our solar system. Could Ceres, with its unique composition and history, be a host to life, or at least to the conditions that make life possible? While we don't yet have definitive answers, these findings have opened up new avenues of exploration and inquiry, deepening our understanding of both Ceres and the solar system as a whole. Ceres is often described as an icy world with a rocky yet porous surface, a composition that makes it stand out from other objects in the asteroid belt. Unlike most asteroids, which are primarily composed of rock and metal, Ceres has a more complex surface made up of water ice, hydrated minerals like clays and carbonates, and other volatile materials. This gives Ceres a lower density than its rocky neighbors, suggesting that water plays a significant role in its overall structure. Ceres' surface layer, though rocky, contains ice and other volatile materials that make it more similar to a comet than a typical asteroid. Beneath the surface, Ceres is believed to have a distinct internal structure, including a mantle made of mud or a mixture of rock and brine surrounding a core that could be composed of denser materials like silicates. What makes this particularly interesting is the fact that water ice accounts for approximately 50% of Ceres' total volume. This implies that at some point in its history, Ceres likely had liquid water, especially if its core was heated by radioactive decay early on. This potential for liquid water, combined with its unique composition, raises intriguing questions about how water has shaped the evolution of Ceres and what role it may still play today. One of the most compelling discoveries made by the Dawn mission was the detection of ammonia clays on Ceres. The presence of these clays suggests that Ceres did not always reside in the asteroid belt but may have formed much farther from the Sun, in a cooler region of the solar system, before migrating inward. This discovery is significant because ammonia lowers the freezing point of water, making it easier for water to exist in liquid form under certain conditions. If Ceres formed in a colder region, it would have had more access to ammonia, which could explain the presence of surface brines on the planet today. These brines are a critical component in understanding Ceres' geological processes and history. The insights gained from studying Ceres help astronomers not only learn more about this fascinating dwarf planet but also provide clues about the formation and evolution of icy bodies in the solar system.